Bring up the slides. Let me first of all welcome all of you. My name is Maron Bieri. I'm a business manager working for the Google Cloud Platform. And next to me, we have Bieri. Jerry is working for Qvik, one of our main partners in this region. And next to that, he is also a Google developer expert. And he's going to give you a high-level overview around APIs, is it? All right, I would say
Something like that.
take it away.
Okay, thank you. We have our slides, yes. So, hello everybody. My name is Jerry, and as Maron told already, I work at a company called Qvik here in Helsinki. And my role in that company is a senior system architect. So basically I'm responsible of our backends and infrastructure. And what Qvik does is we do a lot of mobile. So we do mobile development. We have deployed nearly 200 applications during the years that we've been operating. And most of those applications require a backend, some kind of a backend. Usually these backends has these common terminologies like authentication, connections to external systems like ERPs, CRMs, these kind of internal systems that you don't want to expose publicly. So what you're dealing with mobile is always an API. And there are a couple of challenges in these API worlds that, especially in the mobile scene, you have to actually take into account. First of all, you are not in control. You're not in control of your users. You are not in control of what version of your users are using of your app. So whenever you deploy a new version of your backend and application, you cannot rely that every single user of your application updates to that latest version. So you cannot really just override everything and do breaking changes in your API layer without affecting really seriously your users' experience. So for that, one simple solution for this is API versioning. So what you want to start doing is, if you're not already doing, is versioning your APIs. So when you deploy a new version, you actually specify it in your API paths, and then your clients will communicate with the older one and the newer one, and eventually, hopefully, everybody will upgrade to the latest version. But this is just a simple trick to handle the versioning, which you are not in control from the mobile client point of view. Then there's also the security. As your APIs are publicly available to the internet, you have to secure them in multiple manners. You have to think about who can actually call it. Is it an always use TLS? Just whatever you do, just at least use TLS for your endpoints. But you have to also think about tokenization and this kind of access control, and also on top of that, the user authentication flow. And with token validation, especially if you're using these kind of expiring tokens, you have the problem of when you're doing, your mobile application is doing requests to your backend and the token expires in between, so you have to do a revalidation of that authentication token before you can continue sending those requests. So this brings the problem to yourself as an engineer to the client side, so you have to queue these requests. You have to have this request pool that can handle this case. There are multiple ways to manage this, and also the payloads that you send. You want to think about, do you send them just as a JSON blob as it is, or do you want to do some signing to those requests? Do you want to sign those payloads? And do you want to do some HMAC, these kind of validation checks that it actually came from your mobile client and it is actually valid, so there's no man in the middle? And then one big problem that I see most of the time whenever accessing some APIs is the documentation. The documentation might not match what's actually been deployed, or there is no documentation whatsoever. That's even worse. And one way, of course, to generating this document is documenting your source code. But that brings to the solution that can you really handle safely those versionings, those old versions of that API? If you change the documentation in your source code, what happens to the previous version, previous documentation? Is it still live, available, and all of this?
So I only hear challenges so far. Do you also have a solution for it, or what?
Sure. Basically, what we can do as a solution is use OpenAPI. Open API, what it is it's this Open API Foundation for beginning in November 5th, 2015. It got founded by Google, IBM, Bearmind, as an initiative to actually describe these RESTful APIs in a common manner. And what it is that it doesn't lock you in any kind of framework or language. It's completely vendor-free, and it's open to the world, so there's no one to be paid for or this to be able to use the Open API specification. And of course, it's not the first attempt in the world to create these kind of open specifications. There has been numerous one of these like Copra, VSDL, VADLs, but the main problem with these kind of standardization attempts were that they usually were platform specific, language specific, framework specific, and usually even vendor logged in. So you couldn't really openly use them, you had to pay for someone, etc. So they didn't really get that much attraction from the developer community. But as the Open API initiative's focus is mainly on creating, evolving, and promoting these open specifications, it enables the developers to actually move forward. And you may know, some of you who are at least developers may know that there is the definition called Swagger, and that's actually exactly what Open API is. SmartBear were kind enough to lend their format, the Swagger format, to this initiative, and it has been now developed to version 2 already, with this whole initiative platform. And it's, as you can see, it's basically a YAML or JSON definition of your API. You define your paths, you define your payloads, requests, response bodies, etc. Also, you define what kind of authentication you want to use and that kind of things, straight in that. And that works as a documentation. You can read it as a HTML document through the Swagger editor, in example, or you can generate this as static content. And also, you can generate your clients from this. So you can generate different kind of clients for different languages automatically from this definition. And also machines can understand this language. When you expose a Swagger, this Open API, you have an option to actually expose this definition of your service so machines can know how to call your APIs. So who are actually the companies behind this thing? There are a couple of good names, as you can see, that are participating in and are inputting and contributing to this. So it's not just a random open source project, it's actually on Apache Linux Foundation collaborative project. And yeah, here you can see there's Google, IBM, PayPal, all of these great companies investing in this to get a more consensus way of communicating through APIs.
That sounds great. I see also IBM in there. I think it's very good, open APIs, but how can I integrate that into my own application?
Yeah, well, that's basically a pretty good question and also a pretty simple answer. There is multiple ways, of course, how you can do it. You can start it even today just by writing your API documentation with this. That's the simplest way to go. But if you want to actually manage your APIs in an efficient and powerful way, in Google Cloud Platform, there's this feature called Cloud Endpoints. With Cloud Endpoints, you develop, deploy, and manage these APIs. So you specify your APIs with this Open API specification. You deploy that YAML file or that configuration file to Cloud Endpoints, and what you get is mainly, these are the key features that you get for free on doing that. You will get authentication, controlling access, all of these, so you don't have to worry about it. You don't have to program any of the API authentication, token validation, revalidation, token expiration. You don't have to worry about that. The Cloud Endpoints, or actually the extensible service proxy, how it works, is handling. You also get central logging and monitoring for all of your API requests and all of your API users. So if you share your API, you can actually see the monitor, the tracking and logging and these traces of how that your other user, external user, is accessing your API. And you can trace the latencies. Okay, this and this method is actually taking this long to execute. There might be something wrong with it. Let me investigate. And the speed and scalability, unparalleled speed and scalability amongst any other API gateway solution. Why? Why is that? Because, well, before actually I'm going to that, this is the screenshot of the Endpoint Dashboard. So where you can actually see the monitoring results. So you can monitor as a whole, you can monitor per request, per user, and this is actually the same dashboard that Google uses internally to manage all of their, to monitor their APIs. So all these APIs that you use from Google Clouds, Google Services, they actually utilize this already. So you know it can handle massive amounts of traffic. And this is how it works. I'm not going to go through all of this, but how it basically works is that when you have your application container, so with that container, next to it, you insert this Elastic Service Proxy, which is basically an Nginx-based proxy service. It's a container that lives beside your container. So it scales whenever you scale your app, it scales with it. And with this infrastructure, you don't have any network hops of doing your API gateways. So this is really crucial. The performance, all the monitoring, logging, the authentication, all of these, you get in less than 1 millisecond overhead compared to anything else. If you have an API gateway service somewhere externally, your clients connect to that, and that connects over to internet, back to your gateway. There's always network hops. There's always latency accumulating from that. But using this extensible service proxy or cloud endpoints, you don't have that restriction. You don't have those network hops. It comes straight from the load balancing to your ESP, and the ESP sends it straight out to your container, to your application logic. And as I said, it's completely language and framework independent. So you can continue doing your backends in whatever language, whatever frameworks you wish, and just implement the ESP container next to it. Also, it gives you the freedom of choosing your own transport protocol. Currently, most of these APIs that we use and expose these days are RESTful JSON APIs. But also with cloud endpoints, you have the option to actually go with gRPC, which is, in a sense, it's a protocol buffer HTTP2, so it's a binary stream protocol and IDL language. But the main point here is also that you don't have to, again, if you want to use gRPC in your new APIs, you don't have to change your code at all. What cloud endpoints and this ESP does for you, it has a gateway to translating between these. So if you want, you can communicate, you can implement your backend with REST, and you can actually communicate to your endpoint with gRPC. So you can build these efficient mobile clients communicating already to your existing API with gRPC by using cloud endpoints. And I find this really, really powerful feature, because this is example the way that Google these days offer. If you're a user or consumer of Google APIs, you have the possibility to use the REST and gRPC APIs. And this is a beautiful way of accomplishing that.
Great, thanks. So maybe we should have prepped it more about gRPC. What's that?
Sure. How many of you know what gRPC is? 2 hands. Exactly. Great.
I'm not alone, gladly.
So in a nutshell, what gRPC is, it's an interface design language made to describe RESTful RPC, RPC APIs, not RESTful, but general RPC frameworks. So it's designed from the ground up for mobile and on top of HTTP2. So it really uses binary streams, and actually there is a bidirectional streaming support. And it's lightweight, point-to-point connected, and you have plugins, so you can enable these plugins in your gRPC streams that enable you to do things like authentication, different kind of message validation, all these before it even hits your servers or your clients. So you can do this on the wire. And you can learn more about that on grpc.io. It's basically you define your service once and generate over 10 plus languages your server and client codes. So how it works is you define your service, you define your methods in that service, you define your payloads, your responses, and then you call this generator that generates your client and server stubs, which you can then inject and embed on any language that you prefer to your application. And they communicate straight with each other without you needing to do any kind of translation work. So this is a really powerful feature, and this is it's a packaged binary stream. So What I can say, it's really, really powerful and fun to use. And as I said, you're not depending on Google Cloud Platform. If you're running on AWS, if you're running on Azure, if you're running anywhere local containers already, you can take use of cloud endpoints. You can specify your APIs, your existing APIs with the Open API spec, deploy it to a cloud endpoint, manage credentials, and share that API with other developers, but you can run your backend wherever you want. Because as it is a container that runs besides your container, you can really literally run it anywhere you want. For us, in a Qvik, we use Kubernetes heavily. We use Container Engine in Google Cloud Platform to have zero management, basically. We want to enable us to actually concentrate on developing and not maintaining. So that's why we forward our traffic to Container Engine. But there, of course, there's an option always. You can deploy to an App Engine. You can do your backend in App Engine also. If you drop to your existing App Engine application this Open API specification file, the App Engine knows that you want to deploy endpoints and does it for you. So you immediately get the Endpoint Dashboard with monitoring and all of these available for you. Also, it's not necessary, as Cloud Functions, it's currently still in alpha, but Cloud Functions expose HTTP themselves, so you don't need to have any kind of load balancing to call Cloud Functions, but you can, in the future, call these Cloud Functions through these endpoints also. So, as I said, as a recap, it's fast, it gives you superpowers without you needing to code it, it gives you documentation, all of these kind of things, so you don't need to maintain them. It supports all this versioning, security, all of these comes for you for free, and you can run it anywhere. That's basically my take on how to build the next generation, future-proof, powerful APIs, and saving you time to actually concentrating on your problems and concentrating on the backend logic of connecting to these external services and not worrying about the communication between your client and your backend. Thank you. That's from me.
Thank you, Bieri. Cool.
That was a bit of a mouthful. I think I went too fast.
Oh, that's
Sorry
fine.
about that.
Are there any questions in the audience? Anyone? Once?
Going once.
Twice? No. Thank you very much, everyone.
Thank you.